Hi guys, this is a little impromptu video to answer a question to one of my viewers that made a comment on one of the videos. He made a comment on he actually asked two questions, so we'll go through two things. But he made a comment on the when I was doing the airline TRF radio. He's seen that video yesterday or so. It was part 5 where I was talking about bypassing the primary on the Interstage transformer, the number 27 tube, and then the two push-pull 45s. And let's see, he asked about the turns ratio. Let's see. Bypassing the primary of the audio coil, the capacitor works. You want to know how it worked, and you want to know about the turns ratio. Alright, I'm going to be doing a video that deals with impedance matching, that deals with the turns ratio. But suffice it to say, basically what had happened was this transformer, the primary, burned out. Now it went to B plus or a 7K resistor, but it had the transformer, the primary, was burned out, so it was no longer. I just basically disconnected it because it was open somewhere inside. So we'll disconnect it here. Now, his question about the turns ratio and impedance matching, basically two things happen with interstage transformer like this. One thing you want to, you've got a certain amount of plate resistance and impedance on your plate, and you want to match it up to the grids on the next tube, its impedance. Well, in actuality, this is not so much like an output transformer where you have an interstage transformer. It's acting more as a coupling, a way of coupling this tube to these two tubes. In a case like that, the windings are wound a lot closer to each other, more like a 3-to-1, 2-to-1, something like this, where an output transformer you may be seeing as high as 40 or 50 or 60-to-1 sometimes. So all you're wanting to do here is the impedance for these guys, the grids, basically is derived from the secondary coil. So the loads for the load that you would need for your grids, that is tied to ground, or could be also tied to a negative supply, if you was doing that, like a lot of battery operated radios are. Either way, that's derived actually directly from the coils themselves, and actually more or less has nothing to do with the primary, but has to do with the inductive reactance of the coil, its resistance in the winding, DC resistance, and what they call interwinding capacitance. On the primary, the same thing actually happens. I need to develop a load for this plate to get the tube to operate. It has to have a load that it can drop a voltage drop across, that then can be transferred to the grids, or passed on to the grids of the next tubes. So I need a load resistance here. Well, that was done by the primary. Again, basically the same thing, the inductive reactance, the coil resistance, DC resistance, and its interwinding capacitance. Now there is a certain amount of what they call turns ratio impedance match or reflection, where some of this impedance here is reflected back here to pick it up. But I don't have to worry about that. All I got to do is give this tube a load. And this is a number 27 tube. And a good load for a 27 is somewhere around between 20 to 30K, 20 to 30,000 ohms. I already have a 7,000 right here. So what I did was I added in, at this point, a 20K resistor. And basically what I added in is 20K 2 watt. There's some current going through this, so I wanted to make sure I got good wattage there. So 2 watt will be perfectly fine. It's going to drop probably somewhere around about a little over 1 watt. Okay, that's fine. That gave me my load. That's what this primary was originally doing, besides being inductive coupled. So now I got my load, and I wanted about 27K. Well, I got 7K here and 20K here, so across my entire B plus, from the B plus to the tube, I got 27K. Now all I got left is I still got to get this tube coupled here. Well, then all I did was I just took it and put a capacitor in and hooked it to the secondary winding. And that can be various size. I think I used, I don't recall exactly, but I think I used a 0.1 microfarad. You can use 0.47, 0.22, 0.1, 0.05. You know, they're fine, but I think I used a 0.1 microfarad cap. Now, I explained before, as far as phase inversion, it still works because this winding is still attached. The winding can care less whether it's inductively being coupled and it's getting a signal this way or it's getting a signal at one end. At one end it acts as an auto transformer, and this winding will first get a signal. The field will build up because it's between here and ground. So the field will build up. As that field builds up, it cuts across this one, but in the opposite direction. It will induce the voltage in the opposite direction. So if this one's going this way, this one will start developing this way. And then on the next part of the sine wave, it goes this way. So effectively, we still have the phase inversion to operate the output tubes. But the biggest thing is, this is no different than more modern day radios where your tubes are resistive coupled with resistors. Basically, you'd have a tube and another tube. You have the plate here and the grid coming through here. And out of this plate, we come down, we come to some resistor, load resistor, would come off and come down with a capacitor for the coupling. And on the grid here, we'd have another resistor, and that would generally go to ground. This is actually the same thing as this, except I have a resistor here, and then this coil, the secondary, is acting like this resistor here. It's providing the actual match and developing the impedance for matching for the grids. And these resistors would be sized so that I got a good load for this that matches up with what I need for this tube to operate and that can be any various sizes. In real modern, much more modern, you'd see probably about a 470K there, or 47K or something of that nature, and about a 470K here. Sometimes you may even see them being the same size. But this really took place of your transformer as time moved on, because this stuff started getting expensive. Capacitors started getting better, resistors started getting better, so they opted for this. This is a lot cheaper than this. But back in the day, this was the cheapest route and the best route to go, because large resistors with high wattage was kind of expensive and not always reliable. Fairly decent size coupling caps, again not extremely reliable. So the Interstage transformer was the best way to do it for coupling. It's only here for the most part just to couple each stage. But that's how I got past this matching. This 27K matches out this tube just fine. This secondary is still doing its job of matching the grids. Now, the other question that was asked had to do with the tuning circuits. Mainly because he's never seen a TRF radio before. And let's see. He wants to know if the capacitors are in parallel with the coupling transformers. Also want to know if all four sections were identical. Yes, all four sections are definitely identical. And basically, how these work, they work on a resonance circuit, and how that works is you have, well, let's just say you got your antenna coming in here. Take the ground, and we have another coil here. You have one coil, your first coil. This coil here will be connected across our tuning condenser. That makes a tank circuit. Now this is going to feed in. One side's going to go to ground. The other side is going to go to the first tube. And then this moves on in a TRF. This will continue on, and it will go to the primary of another transformer, but in this case it'll go to B plus, and then the secondary, which goes to ground, and you'll have another capacitor, another section of the tuning condenser, and that again goes to a grid of the next tube. And this continues on. In this particular radio, 3 tubes, 4 sections. But it's this tank circuit. This is one of the sections of the tuning condenser. Each one of these were all connected together in that gang tuning condenser. And normally you would see it probably, you know, at least more modern day drawings, you'd see a dotted line that go across, going to each one, just to tell you that it's connected. And there'd be 4 of these. 3 tubes, 4 sections. Each one is tuning, and they're all since they're all on the same tuning condenser, they all tune at the same time. So if everything is working correctly, they're all tuning exactly the same frequency. And what happens is when this is tuned, as you turn that tuning condenser, this tank circuit will only resonate at a certain frequency. So if you tune it to, say, 550, then only 550 is going to get through. If you tune it to 1040, only 1040 is going to get to, or anywhere along that broadcast dial, wherever you tune it to, that's the only frequency it gets through this tank circuit. It, what they say, attenuates or lowers or drops off anything else that's trying to get in, and only allows the what you tune to get through. And these are all tied together. Now they did, I don't remember, now some of these radios, this one did not. Some radios there will be a little adjustable patter caps that's on the tuning condenser to fine tune it so that everything's right on the money, so that this one's definitely tuning to the same frequency as this one, but all four have to tune to that. Let's say you've got a radio station at 600 and that's what you want to tune to. This one has to tune to 600, this one has to tune to 600, the next one has to tune to 600, and the next one has to tune to 600. And the only other thing that happens is at 600, this goes through, gets amplified, goes to this one, it's tuned at 600, goes through and amplifies. That's what a TRF is doing. We're having several sections of amplification on that are tuned radio frequency amplifiers. Each one's tuned to whatever station you've got set on. Now early TRFs did not have, like this one had, where it's all on one gang. Now some earlier ones like the Atwater Kent 67, Atwater Kent 40, and various other ones, they had separate condensers, and they had a little pulleys on them like this, and they would have their brass pulleys with brass, thin brass like belts that came around that tied them together. And this one would have the knob on it, and as you turned it, of course, it turned the others. And these would be adjustable so that you could get them adjusted just right, so that, again, this one's tuned to 600, this one's tuned to 600, and this one's tuned to 600, whatever radio frequency. When you go further back than that, they did not have this. They were just, you just had knobs on the front of the radio that had numbers 0 to 100, and you did the full complete tuning. You turn this one till you might, or at least somewhere where you think you can pick up a signal, or turn it a little bit, turn this one a little bit. The numbers allowed you to get close, and then you fine-tuned each one. It was kind of a skill, a learned skill that you had to do to get each one of these and get the radio tuned in. And sometimes it could take a little time, especially if they're off a little bit, but you had to adjust all three knobs. They weren't connected together in the very earliest ones. But anyway, that's tuned radio frequency. It just, unlike super heterodyne, it's got 2, 3, 4, 5 stages of amplification. Each stage will have a tank circuit. In other words, there'll be a coil that's connected to the one section of the tuning condenser in parallel, and that when that you adjust that capacitor, you tune it in to a frequency, and each one will tune into the same frequency if everything's set up right and adjusted right, and that just feeds out to the first amp, gets amplified, its signal goes to the next stage, next tuning coil and condenser, next tank circuit, and on as it goes until everything's full until it gets past all the amplification stages. I hope that kind of answered your question on that. If you have any other questions, go ahead and answer. The other thing, well, yeah, if you have any other questions, just leave a comment on this video. Or if anyone else has any other questions on it, leave a comment and I'll get back to you on that. So, that's basically it for this video. And I want to thank everybody for watching, for your comments and stuff. And the next video that I'm going to try to get done, and hopefully tonight, will be the dealing with the turns ratio matching transformer, and you know, like an output transformer. In fact, that's what I'm going to look at, is an output transformer, and how you figure out what you need and stuff, and kind of get a general sense. We're going to look at a 6L6 tube just in general. This is not really something that I'm doing. This is more for the transformer and the impedance matching as it is for actual design of an audio amplifier stage. But we will look at the 6L6 and look at what's needed for a transformer for it, and say like a 4 ohm speaker. So until the next video, you guys have a good evening, and I'll see you on the next video.